Welcome students to yet another experiment in electricity. Now this is going to determine the frequency of alternating current, that is AC, that we use in our homes, the usual 220 volt supply, by using a sonometer and a magnet. The working formula will remain to be frequency is equal to 1 by 2L square root of T by N. Now obviously, since we are using a sonometer, L will stand for the length between the two bridges when you set your experiment. T stands for the tension in the sonometer wire, which is equal to the product of the mass which is hanging from the wire multiplied by acceleration due to gravity. The small m in the denominator stands for the mass per unit length of the sonometer wire. It depends upon the material that you have chosen for making the wire. It can be iron or brass. Now, to give more meaning to this formula, let us connect the circuit for determining the frequency of AC mains on the table. So now we are on the setup of determining the frequency of the AC mains. These are the AC mains through which you get a constant current supply in our homes, schools, etc. But then, as you can see, this AC at 220 volts is connected to a step-down transformer. The purpose of the step-down transformer is to lower down the value of voltage from 220 to a still lower value like 2 volts. Now further, after stepping down the voltage, we can see the sonometer apparatus. This is the wire of the sonometer. These are the two bridges on which we will be adjusting the length of the sonometer wire. For providing us a uniform magnetic field, we are using a horseshoe magnet. Now, at the other end of this wire, you can see there is a pulley which shifts the wire of the sonometer to some weight which will be used in the experiment. Now let us see how our apparatus will work to determine the frequency. Now to begin with, I will give you a small briefing on the theory behind this apparatus. Now, after stepping down the voltage, some current is allowed to pass through the sonometer wire. Now, there is also a uniform magnetic field provided by this horseshoe magnet. We have learned in our junior classes that whenever a current passes through a conductor and there is a normal magnetic field near it, then there is a force generated in the conductor. The same will happen here, that is, this current carrying conductor will experience a force in a direction perpendicular to the direction of the wire as well as to the needle. To get the exact orientation of this force, you can apply the Fleming's left hand rule, which you already studied. It means this wire will be going up and down for every change of voltage. For the positive direction of the voltage, it may go up, and for the next half, that is the negative part of the AC voltage, it may move down. It means for one cycle of up and down, this wire goes up and down once. Greater the frequency of the AC main that you supply, more will be the vibration of this wire. Now, our basic motto will be that we will be taking current through this wire and we will be supplying certain voltage by the step-down transformer. By adjusting the length of these two bridges, which you can see right now on the sonometer table, we will be adjusting the length of the wire going through the magnetic field. At an appropriate length, you will be finding that there are vibrations created in this string. It is because of the resonance between the natural frequency of vibration of the sonometer wire with the frequency of the AC mains that we are providing from the transformer. When the vibrations are loud enough, that is, when the amplitude is maximum, you find out the value of the length of the wedge on the right side, similarly the wedge on the left side. If you subtract these two positions, you will be obtaining the length in between the wedges. Now this you get for a particular value of weight that you have suspended through the sonometer wire. This constitutes your first reading. To change the reading further on, you can add on more weights to the hanger supplied with it. Now I have increased the weight on the hanger by 100 grams, and now we will try to observe how we will be able to take the readings of resonance in this setup. We are trying to move the wedge. We can easily observe that the wire is slowly vibrating, and here you see the wire is vibrating in the resonant position with the maximum amplitude. Students, can you observe this?
Yes, ma'am.
Up and down motion of the wire? In this position, when you are getting the resonance, you can find out the value of L1, that is the position of the first wedge that you assign, L2, the position of the second wedge, while you subtract to get the total length in between the two wedges. The value of mass per unit length of this wire is shown on this slide. This value can be easily substituted in the formula to calculate the frequency of the AC main. The formula remains to be frequency is equal to 1 by 2L into under root of tension divided by mass per unit length. After observing the positions, we can switch off the supply in order to avoid the unnecessary heating of the wire. Similarly, you can add on more weights to the hanger and thereafter adjust the length of either of the wedges in order to obtain the next resonant position. Like this, for different values of weights that you take in the hanger, you can observe different values of length in the resonance position. After substituting them in the formula, we can average over the frequency of the AC mains.
Excuse me, ma'am. In this experiment, why we use a magnet?
Now, the reason of using this magnet is we want a uniform magnetic field, because without magnetic field, a current carrying conductor cannot experience a force. Thereby, we use this horseshoe magnet for applying the magnetic field to the current carrying conductor. Do you know what is the material of this wire of the sonometer? Now, this can either be iron or brass. In this particular setup that you can see, the material of the wire taken is brass.
And why are we using step-down transformer?
Well, that's a good question. As you know that step-down transformer always steps down the voltage that you are getting. Now, if you are getting 220 volt through this, you will step it down to, let us say, as low as 2 volt. The reason why we are not using directly 220 volt here in the sonometer wire is, more the voltage that you give to this conductor, the greater will be the heating produced. If the heating is too much, it can even burn away the wire while you are doing the experiment. That is why it is always preferable to work with lower voltages.
Wire is made up of which metal?
Well, the sonometer wire that you can see is made up of a non-magnetic substance. It can be brass, it can be copper. In this case, we have taken a brass wire. The reason for this wire to be non-magnetic is that it should not get its own magnetic field and it should not superimpose with the magnetic field of the horseshoe magnet that you supply. Also, while doing the experiment, you should bear one precaution in mind, that while you move the wedges to take the readings of the resonant length, you should move them by small intervals each, so that you may not skip off the fundamental node of the resonance. of this wire. Similarly, while you change the weights in this hanger, you should be doing it stepwise. At once, a large weight should not be attached with this wire. The reason being, we do not want the wire to show a very large extension by putting in a large weight. Also, that the horseshoe magnet should preferably be set in between the position of the two bridges. So this is how you will be determining the value of frequency of the AC mains.